Use thevenin's theorem to find the current flowing in the 10 ohms resistor from the circuit shown. This is the given circuit. Solution. Step 1. In the first step, we are going to remove the R load, that is the load resistance. So this circuit will be that is, we are going to open circuit this R load and replace it with VOC, that is the thevenin's voltage. So now, after replacing this VOC, then we are going to find the current flowing inside this resistor by Ohm's law, but we are going to consider only the networking loop. This loop, that is, this R and this resistor, they are in series. R equivalent is equal to 2 plus 8, which is equal to 10 ohms, and our V is equal to 10 volts. So now, to find the current flowing, V is equal to IR. I is equal to V all over R. This implies that I is equal to 10 volts. 10 all over our equivalent resistance, 10. Therefore, I is equal to 1 ampere. So now, after finding this current, then we find VOC. So now we find VOC. VOC is equal to IR, which is equal to, the I is 1 times this 8 ohms resistor, 8, which is equal to 8 volts. So now, after finding this, we are to find R thevenin's. So to find R thevenin's, we are going to short circuit the voltage. Then this will be so we can find our R thevenin's looking inside the circuit. This is 2, this is 8, and this is 5 ohms resistor. So when we look inside, these 2 and 8 are in parallel. Then 2 times 8 all over 2 plus 8, then plus the 5 ohms resistor in series, plus 5, which give us 16. 2 times 8, 16, all over 2 times 8, 12, 10, then plus 5, which give us 6.6 ohms. So now this is the R thevenin's. So now, by taking back the R load and making VOC and R thevenin's in series, this is the VOC that we find as 8 volts, and this is the R thevenin's. So we bring back the R load. So now we are going to find the current. I is equal to V all over R, and I will be equal to, the V is 8 all over 6.6 and 10 are in series. 6.6 plus 10, which is equal to 8 all over 16.6. Therefore, I is equal to 8 divided by 16.6. that is 0.4819 ampere.